This week we are going to be talking about reaction equilibrium. And so I thought I'd take a moment to explain part of the activity that you're going to be doing this week because it's kind of a little bit challenging. So I'm going to use an example that's going to be similar to the one you were going to do in there. So you can use this one as a model. So what we are going to say, and you'll learn more about this as you read through the activity, so this might be something you want to come back to when you get to that point in the activity, but what we're going to say is that we have this reaction that is the reaction of A, our reactants, producing B, our products. And what we're going to say is that initially we're going to start with 5 moles of each. And I'm actually going to say 5.00, so we're rounding to the hundredths place. So we initially have 5.00 moles of A and 5.00 moles of B. Now what we're also going to say is that throughout this reaction there's a specific rate that each one, so the A becomes B and B becomes A. And we're going to say that it's, so you follow my arrows here, so we're going to look over time and we're going to look, I kind of have a data table set up here. But during our first minute, 60% of this original amount of A is going to become B. And during this minute at the same time, 20% of the initial amount of B is going to become A. So I'm going to write above the arrows here, 60% this direction to the right, to the reactants, or I'm sorry, to the products, and it's 20% of the product B becoming the reactant A. So our process will be this. Since we know initially we're starting with 5 moles of A and 60% of it is going to become B, let's find out what 60% of that is. So punch that in your calculator, 5.00 times, you can convert 60% to a decimal, but really it's going to be 0.6. And so that means it's going to have 3, but we're always going to put to the hundredths place, so make sure you put your 0 zeros there. So 3 moles of A is going to go forward, and so this is going to be like we're losing this much. So 3 moles of A is being lost, but that means that 3 moles of B is being gained. So you're going to put that same amount but a plus sign on the other side. Well, now let's look at B. We know that 5 moles is what we start with, and 20% of it is going to become A. So let's find what 20% of 5 is. So 5.00 times 0.2 gives us 1. So we are going to be losing 1 mole of B, but we're gaining 1 mole of A. And so now what we're going to do is find our total amounts of each, and really, yeah, so we're looking at, we're subtracting 3, so we have 2 moles of A, but we gained 1 from over here, so that would give us a total of 3 in the end. And over here we had 5, we gained 3, so now we're at 8, and then we're subtracting 1, so now we are at 6. I'm sorry, 7, if I could do my math, right? So 7.00. So now these are the amounts of each we have, and they're going to go through the same thing. The 3 moles of A that we now have, 60% of it's going to become B. So 3 times 0.6 is going to give us 1.8. So change forward is we are losing 1.8, but make sure it's 1.80 so that you keep the hundredths place, which means that B is gaining that 1.80. Well, the 7 moles of A, or a B that we now have, 20% of it is going to become A. So 7 times 0.2 gives us 1.4. So we're going to be losing 1.40 moles of B, but we are gaining 1.40 moles of A. So what's our total amount left now? Well, we had 3, so we'll do this on the calculator here. 3.00 minus the 1.80 gives us that, but we're adding in 1.4, which is going to leave us with 2.60. And over here, we had 7. We're adding 1.80, and we're subtracting 1.40, which is going to leave us with 7.4. Okay, now we're going to continue that same process again. Now we're starting with 2.60 moles of A, and we know that 60% of that is going to become B. So 2.6 times 0.6 gives us 1.56. So we are losing 1.56, but we're gaining 1.56 over here. And now the same thing's going to happen again. We're taking 20% of the amount of, B that we have. So 7.40 times 0.2 is going to give us 1.48. So we're losing 1.48, but we're gaining that over here. So now let's find our amounts. We had 2.60 minus 1.56 plus 1.48. So now we have 2.52 over here. And over here, we had 7.40 plus 1.56 minus 1.48 gives us 7.48. All right, let's repeat this again. 60% of A is going to become B, so 2.52 times 0.6 gives us, remember we're rounding to the hundredths place, so 1.51, so we're losing 1.51. Which means we're gaining 1.51 over here. And 20% of what we have for B is going to become A, so 7.48 times 0.2 gives us 1.496. We're round to the nearest hundredth, so we're losing 1.50, but we're gaining 1.50 over here. So now let's look at our totals. We have 2.52 minus 1.51 plus 1.50 gives us 2.51. And over here, 7.48 plus 1.51 plus, minus 1.50. If I could get that right. 1.50, there we go, gives us 7.49. And now let's do this again, one more time. 60% of this, the 2.51 times 0.6, is going to give us how much is going to become B, which round to the hundredths place is 1.51, but we're subtracting it, meaning we're gaining that over here. And the 7.49, 20% of it is going to become B, 20% of B is going to become A. So 7.49 times 0.2 gives us 1.498, but round to the nearest whole number, which is 1.50, and we're adding that to this side. And now I want you to notice something. Isn't the amount that we're changing forward and reverse in the fourth minute the same as what we're changing forward and reverse in the fifth minute? And the same thing applies for B. Changing forward and reverse is the same in the fourth minute as it is in the fifth minute, which means this reaction has really reached equilibrium. The same amount of product is becoming reactant and the same amount of reactant is becoming product. But let's finish filling out this chart here. We have 2.51 moles of A. We are subtracting 1.51, and then we're adding 1.50, which gives us 2.5. And over here, 7.49 plus 1.51 minus 1.50 gives us 7.5